penuh kesungguhan. Akademi Youtuber Malaysia, rangka laksana dengan jitu, penuh bermisi Guru AYU, mencapai misi yang satu, permisi kita bantu.
Tahniah. Siaran langsung ini dibawakan khas kepada anda oleh Akademi Youtuber Malaysia. Tumpukan perhatian anda. Siaran langsung akan bermula sebentar lagi. Link sijil akan diberikan di hujung siaran ini. Pastikan diisi dalam tempoh yang ditetapkan. Terima kasih. Indah berbalam si awan petang, berarak di celah pepohon ara. Pemanis kalam selamat datang, awal bismillah, pembuka bicara. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Salam sejahtera dan selamat datang ke tuition online percuma yang dibawakan khas untuk anda oleh Akademi Youtuber Malaysia, Kelab Guru Malaysia dan e-didik Malaysia. Bermula percuma, selamanya percuma. Jadi sebelum kita bermula, seperti biasa kita mulakan dengan kitab Al-Fatihah. Bagi yang bukan beragama Islam, anda boleh bertafakur mengikut kepercayaan masing-masing. Al-Fatihah. Amin, amin, amin ya rabbal alamin. InsyaAllah mudah-mudahan kelas kita pada malam ini mendapat berkat dan rahmat pada Allah Subhanahu Wa Taala. Bagi guru-guru dan murid-murid yang sedang mengikuti kelas ini, boleh respon cikgu tak kalau anda boleh dengar saya dengan jelas? If you can hear me clearly, can you please type 1 in the live chat? Thank you. Okay, and students, for this evening, we will continue our lesson on 6.3, image formation by lenses. Okay, dan untuk pengetahuan anda, cikgu ada sediakan pautan latihan pada pin message. Anda juga boleh dapatkan pada deskripsi video di bawah. Okay, thank you very much. Terima kasih JTZY for your response. Okay, anda boleh dapatkan, boleh muat turun nota yang cikgu kongsi dalam link pada pin message ini yang tertera pada skrin sekarang. Anda juga boleh dapatkannya pada deskripsi video. Kalau tak sempat muat turun dan cetak sekarang, boleh cetak keluar selepas ini dan anda boleh tonton semula video ini untuk mendapatkan jawapan penuh. Alright. Okay, so without further ado, tanpa melengahkan masa, mari kita mulakan kelas pada malam ini. Terlebih dahulu, seperti biasa, ini adalah jadual kelas bagi subjek fizik pada minggu ini telah disampaikan pada Jumaat lepas. Pecutan akhir SPM 2025 siri 1 yang disampaikan oleh teacher Slinda Nordin. Siapa yang terlepas kelas ini, anda boleh tonton semula ulangannya di channel teacher Slinda Nordin ataupun boleh layari portal www.akademiyoutuber.com. Okay. Dan untuk malam ini, cikgu akan teruskan untuk tajuk yang ketiga, 6.3 image formation by lenses untuk kelas DLP. Dan ini adalah ahli panitia fizik di Akademi Youtuber yang telah banyak membantu saya untuk menjalankan kelas tuition online secara percuma bersama dengan Akademi Youtuber, dan cikgu-cikgu ini juga telah banyak menerbitkan video PDPC untuk fizik tingkatan 4 dan 5 sama ada dalam bahasa Melayu ataupun bahasa Inggeris untuk kelas DLP. Jadi dari mana nak dapatkan video-video ini? Anda boleh muat turun aplikasi ini Akademi Youtuber di Android anda. Kita ada setakat hari ini lebih daripada 26,000 video PDPC yang dihasilkan oleh guru-guru sukarelawan AYU dari seluruh Malaysia yang merangkumi subjek daripada prasekolah hinggalah ke pra-universiti. So dalam apps ini, video-video telah disusun mengikut subjek, mengikut tingkatan dan juga mengikut tajuk, semoga yang membantu anda mengulang kaji dengan lebih baik. Okay, anak-anak murid sekalian, students, if you are ready and good to go, so let us begin with our discussion on image formation by lenses. So far, altogether there are 4 learning standard. Ada 4 standard pembelajaran yang perlu anda kuasai. So the first one will be 6.3.1 to identify convex lens as a converging lens and concave lens as a diverging lens. So kita akan pelajari kanta cembung sebagai kanta penumpu dan kanta cekung sebagai kanta pencapah. Alright, okay. So what is lens? Apa itu kanta? Okay, students, what is lens? If you look at this diagram on top are considered as lens, but not the diagram that below. So even though they are both made from glass, why the top one considered as lens and why the bottom does not consider as lens? Okay. So apa itu kanta? Kanta adalah objek transparent, contohnya kaca, perspek ataupun plastik yang mempunyai dua permukaan, di mana salah satu permukaannya mestilah berbentuk lengkung, baru dia dikategorikan sebagai kanta. So what is lens? It is a piece of transparent material such as glass, perspex or plastic, okay, which has two surfaces. You can see the first surface on the left and the next surface on the right, where one of the surface must be curved. Okay, so the condition is the transparent material must have two surfaces where one of the surface must be a curve. That is lens. Okay, and when we talk about lens, the light phenomenon that occur when passing through lens is refraction of light. Okay, where the light refracted when passed through a lens due to they're propagated through two different medium, okay, with different optical density. So the light traveling from air entering the lens. So there are two medium there of different optical density. So what happened, as we learned before in chapter 5, the light, or in 6.1, the light will undergo refraction, okay, changing in direction due to the changing in speed when traveling through two medium of different optical densities. Alright, okay. So what are types of lenses? Apa jenis kanta yang ada? So generally we have two types of lens. Okay, the first type is called as convex lens. The second type is concave lens. So you can see a different shape of convex lens with their respective name according to their shape. Okay, we have biconvex, plano-convex, or meniscus, convex, concave, meniscus. Okay, and for concave, we have biconcave lens, plano-concave, and convexo-concave. So, how to identify convex and concave lenses? Very easy. For convex lens, it is thicker at the center. See, the lens is thicker at the center. While for concave lens, it is thinner at the center. So that is the most obvious difference. Thicker for convex, thinner for concave at the center. All right. Okay, students, if you refer to your textbook, why does convex lens called as converging lens? And why does concave lens called as diverging lens? So this is what happened when a light pass through a convex lens, as you can see there. Okay, this is the first difference. Convex lens is thinner at the center while thicker for concave. So the second difference for convex lens, when the light ray which is parallel refracted inwards and converge on a point. Okay, all the light that parallel to the principal axis will be converged at a point, the focal point, after passing through lenses. So it focuses on a point. That's why we call it as a converging lens. Okay, and for convex lens, student, it has a real focal point, okay, which has a positive value. We will apply this when we are solving a problem using the thin lens formula later in 6.4. Okay, while what happened for concave lens, why does it call as diverging lens? Because as you can see in this diagram, when light ray parallel to the principal axis refracted, it will be refracted outwards and diverge as it comes from the focal point at the front of the lens. So this one converge at a point, focus on a point. This one, it diverge, mean it refracted outwards. Okay. And a focal point for concave lens is said as a virtual because the light ray reflected as appear to be diverged from this point. Okay, it is negative value when we apply the thin lens formula later in 6.4. Okay, so this is the three differences, a comparison for convex and concave lens. Okay, so that is for the first part. What is convex? What is concave lenses? All right, students, now in your textbook, there is an activity as shown here on how to show convex lens as a converging lens and concave lens as a diverging lens. Okay, I believe some of you have conducted this activity with your teacher in school. So this is all the apparatus and material required for this activity. We need a convex lens, concave ray box, power supply, 3 slit plate, and pencil and ruler for drawing. So this is the setup. The ray box, which is as the sources of light. Okay, so this is the 3 slit plate. So we created a 3 parallel light. Okay, entering the lens here. Okay, so what happens, students? You can follow this instruction. Okay, so first we do the setup, trace the shape of the convex lens on the white paper, and then we direct the 3 parallel light from the box. And then, okay, you can read as written from number 4 to number 8. Finally, we measure the distance between the center of the lens P and the point. Okay, and for this activity, this is what you will observe. Okay, when using convex and concave lens. Okay, this is the observation for convex lens. See, all the light will be focused on a point, while for concave, it will be diverged after passing through the lens. Okay, so this is the discussion we may ask for this activity. Okay, what happened to the 3 beams of light after passing through convex lens? So you can see obviously for convex lens, the light ray at the center passes through the convex lens, which is undeviated. This is the light ray that passing through at the principal axis. Okay, while another 2 on top and below, it will be converged at a focal point. Here we have 5 parallel light. Okay, in the apparatus we use 3 parallel lights. All right. While for concave, what happened? Similar, the center line, which is passing through the principal axis, will be undeviated, continue travel in a straight line, while the 2 line on top and at the bottom will be diverged out from the focal point at the front of the lens. All right. Okay. And students, this is the optical terms which you must know very well to understand this topic. Okay, first is the optical center. This is the optical center. Is the point at the center of the lens. Okay, so the light passing through this optical center will not refracted, mean it will continue travel in a straight line, undeviated. And then second, we have the principal axis. This is the center line, straight line through the optical center of the both surface of the lens. And then the focal point. Okay. For convex lens, the light ray parallel to the principal axis will converge at this point after passing through the lens, while for concave, as I mentioned before, the light ray that parallel to the principal axis appear to diverge from this point after passing through the lens. Okay, and the next term is the focal length. It's the distance, this is focal length, distance between the focal point and the optical center. Okay, and object distance is the distance from where we place the object to the optical center of the lens. Okay, 6 is the image distance. V is the distance measured from where the image formed to the optical center of the lens. And last but not least is the axis of lens. It's a straight line through the optical center perpendicular to the principal axis. Okay, this is the axis of lens. Okay. A dashed line which is divided lenses into similar part, right and left. So are you clear with the discussion so far? If you follow me, you can type number 1 in the live chat. Okay. So that is the first part done. Okay, what is convex? What is concave lens? The similarity and differences between both. Okay, now let us go to the second learning standard. Kita pergi kepada standard pembelajaran yang kedua. Okay, thank you JTZY and Tool for your response. Okay, macam mana nak anggarkan panjang fokus untuk kanta cembung menggunakan objek yang jauh. Sebenarnya aktiviti ini agak sukar dilakukan kerana anda memerlukan bilik yang betul-betul gelap untuk menghasilkan mendapatkan hasilnya. But never mind, we look at the methodology first, how this activity conducted. So students, this is the step of estimating focal length of convex lens. Ini ada 4 cara. Okay. Macam mana kita nak anggarkan panjang focal bagi kanta penumpuk. Okay, so what is the first step? So all you need to do is a convex lens and a holder, then a wide screen to where the image will be seen at, and we need a ruler to measure the object, the image distance and the focal length. So what we do, we place the convex lens facing a window where we use a distant object as our object. So in this case, we use this house as our object. Okay, the first step, convex lens directed towards a distant object. So the house is our object. So second, what we did, a wide screen behind the lens is adjusted until a sharp image is observed on the screen. So you face this to the window facing the house is our object, and then we have to move this wide screen front and back. Kita gerakkan screen putih ke depan dan ke belakang sehinggalah kita dapat lihat image rumah yang jelas pada screen. Okay, we adjusted front and back until you can see a sharp image of the house form on the wide screen. And the third step, what we do, so this sharp image on the screen is called as a real image. Student, what is real image? Real image is an image which can be formed on a screen or which can be cast on a screen. Apakah maksud image nyata? Image yang boleh terbentuk pada screen. Okay, itu maksud image data. While virtual image is an image which cannot be cast on the screen. Image maya dia image yang tidak boleh terbentuk pada screen. Itu beza dia. That is the difference between real and virtual image. Okay, then final step, we measure the distance between the optical center of the lens and the screen as the focal length of the convex lens. So that is the final step. So let's say the distance here 5 cm. Okay, we measure from the center of the lens, which is the optical center, until the wide screen. Because for convex lens, the image will be okay. So this is the focal length of the convex lens. Okay, again, the distance between the optical center of the lens and the screen will give us the focal length of the convex lens. Easy. Okay, so I hope you can remember or you can screenshot this for the 4th step to estimate focal length of a convex lens. Okay, students, second activity, okay, this one, to observe real image and estimate focal length. Okay, so for the second activity, you can follow this instruction. Again, we do the setup as shown in diagram. So place the convex lens on the lens holder position to an open window. So we adjust again the wide screen until we form a sharp image on the screen and measure the focal length. That is the distance between optical center, record your reading. So this is similar to the first activity. Okay. But the challenge when conducting this activity is the object must be far enough, okay, for parallel light ray from the object to be converged at the focal point. So this is the big challenge in conducting this activity. If not, they might not have parallel light ray for the formation of image at the focal point. Therefore, the distance of the concave lens from the screen is not exactly equal to the focal length. So this is the challenge for concave lens. Okay, for convex lens, there is no problem. Okay, we can get the image easily, but for concave lens, it is quite difficult to get the result because the object must be very far away so that the light travel in a parallel ways heading to the lenses. So this is the big question, and this is the explanation response to why it is not suitable to be used to estimate the focal length of a concave lens. As I mentioned, this activity is very easy for convex lens but very challenging for concave lens as mentioned here. Okay, the reason. Okay, Lim Jing Sheng, hello, hi, thank you for being here. I really appreciate your presence. Okay. For Bakanjaya student, they will set for physics exam tomorrow. So I wish you the best and good luck in paper 1 and paper 2 tomorrow. Okay, that is the second learning standard to estimate the focal length of a convex lens by follow the 4 step I show you just now. Okay, and student for the third learning standard. Okay, for the third learning standard, we will learn how to determine position and features of image formed by convex and concave. So this is the gist of the lesson. Yang paling penting dalam topik ini is this part, how to draw the ray diagram. So for us to determine the position and characteristic of image formed for convex and concave lenses. Okay, first, so there are 3 rules you can apply in drawing the ray diagram to determine the position and characteristic of image formed by lenses. So what is the first rule? Okay, so students, the first rule, okay, rule number 1, okay, you can draw a ray, okay, which is the first rule, we draw a light ray passing through the optical center as shown in this diagram. Okay, passing through optical center. So what happened? This ray will continue travel in a straight line without being refracted. Remember, any light ray passing through the optical center, either from this direction, from the center of the principal axis, or from down here upward, it will continue travel in a straight line. That is the first rule. Apply the same for concave lens. Okay, the light ray can be coming from this direction as well, passing through the optical center, continue travel in a straight line. Okay, example here, passing through optical center, continue travel in a straight line. Passing through the principal axis, through the optical center, continue travel in a straight line. Okay, that is the first rule. All right. So what is the second rule? So second rule, students, okay, the second rule, okay, for convex lens. Okay, for convex lens, we draw a light ray as shown in this diagram parallel to the principal axis. So where will it go? It will be focus or diverge. It will converge. It will be focus or converge on the focal point. Okay, and when you draw the ray diagram, you must draw the arrow as well to show the direction. Okay, straight line parallel to the principal axis will be converge at F. Okay, second rule for convex lens. And for concave lens, okay, a straight line parallel to the principal axis will be diverge. That is the difference, diverge, okay, from the focal point at the front as shown here. All right, so that is the second rule. And the third rule, okay, the third rule, we can draw a ray diagram for convex lens, a light ray passing through the focal point here. So after the lens, it will be refracted in a straight line parallel to the principal axis. So if you look, rule number 2 and rule number 3 is opposite. Okay, opposite. This one travel straight line and then refracted at F. This one travel at F and then refracted straight line to the parallel to the principal axis. Alright, and for concave lens, for the third rule, the light ray heading to the focal point here, so will be refracted in a straight line, also opposite to the second rule for concave lens. So in order to determine the position of image, you can apply 2 of 3 of this rule. At least you apply 2 of 3 of this rule, and the intersecting point will be where the position of the image is, as shown in this diagram. Okay, so that is the 3 rules of drawing ray diagram for convex and concave lens. Now let us see where the image formed by applying either rule 1, rule 2, or rule 3. Okay, student, for convex, we look for convex lens first. Okay, so the image position and characteristic of image formed by convex lens is depend on the position of object in front of the convex lens, which means the characteristic and position of image is varies. Okay, it is different due to the position of object. So if you look at this diagram, this is how the position of object change from beyond F until it is very close to the lenses. Okay, you can see the position of image. Okay, when the image form at the same side. Okay, first, when the image form at the same side, okay, we call it as a virtual image. And when the image is formed at the opposite side, we will call it as real image. So the image can be formed at 2 possible places, either at the same side of the object or at the opposite side of the object. Our object is the black arrow. Our image is the blue arrow. Here it formed at the opposite side. Okay, and here, there, it formed at the same side. All right. Okay. Then, so we can say either there are 3 characteristics can be written. Okay. First, either the image is virtual or real. As I mentioned, if the image formed at the same side of the object, we call it as a virtual image. Okay. While if the image is formed at the opposite side, as shown here now, we call it as a real image. And then second, it could be upright or inverted. Here now it shows the object is upright. Okay, object above, image also above, so it is upright. And now here you can see the image is inverted. Okay, inverted. Object is upside, image downside, so it is inverted. Then third characteristic, you can talk about the size. Either it has same size, diminished means smaller than object, or magnified means bigger than object. Okay, for example, here now, okay, at this stage, okay, here's the now. Okay, you can see now the image is bigger than the object, so we say the image is magnified. Okay, and when the object is exactly at 2F, the size of the image will be exactly the same. And now you can see, okay, at one position, the image is smaller, so we call it as diminished here. Okay, when the object is beyond 2F, the image is smaller, which is diminished. Okay, so this is the 6 possible places we can place the object or the object distance. So it will give you a different characteristic, and I give you also the application. Okay, so the first position, the object is very far away. So we say object distance is at infinity. For example, when you are using a telescope to observe star or planet, so the object is very far away. We don't know the exact distance, so we say object distance is infinity. Okay, so this is the 2 light parallel from the very far object. So here we apply, if you can recognize, we apply rule number 1, the red line, and we apply rule number 3 here. We apply rule number 1 and rule number 3 from the green arrow. So this is the intersection point of these 2 lines where our image formed at. So by this we can say the image is real. Why real? Because it formed at the opposite side. Object is up here in front of the lens, and image formed behind the lens, opposite side. So it is real image, and it is inverted and size smaller than object, so we say it is diminished. Application, objective lens of telescope. Okay, So now we bring the object closer to the lens. U less than F. Okay, we bring it closer. Now U greater than F. So U is placed beyond to F. So here we apply the red line rule number 1. A straight line passing the optical center continue travel in straight line undeviated, and we apply rule number 2 here. Okay, rule number 2. Straight line parallel to the principal axis and it will be converge at F. So this is the intersecting point between the two light rays. Okay, so again it is real because formed at the opposite side with the object. It is inverted and the size you can compare. Object is bigger, image is smaller, so we say the object is diminished. Okay, where to apply this position? Lens of a camera. Okay, so when you are taking picture, the object is actually beyond the 2F of the lens, camera lens. Okay, now we bring it closer. Now we place the object at 2F. Okay, we place the object exactly at 2F. So we apply rule number 1, the red line, and rule number 2 here. If you want to apply rule number 3 also, no problem. You draw a straight line here to F and it will be refracted straight line parallel. So they will all meet at the same point here. Okay. So now the image is exactly below 2F, has the same size with the object. Okay, and it is inverted, real inverted, same size. So where we apply this in a photocopying machine, photostat machine. Okay, and the fourth position, now we bring it closer. Okay, at a point in between F and 2F. Okay, any point between F and 2F. So apply rule number 1 here, the red line, and apply rule number 2. You can also apply rule number 3. How to apply rule number 3? You draw a straight line from the head of the object through F here. So then you continue draw a straight line. So all the line will be meeting at this point. Okay, so this is the intersecting point where our image form S. So again, it is real because opposite to the object, inverted and magnified. Mean image is bigger compared to the object. Okay, application in objective lens of microscope. All right. And the fourth position, now we bring it closer where U is now equal to F. Object distance equal to F focal length. Okay. So here, if you look, we apply rule number 1, the red line, and rule number, we apply rule number 2. So in this, in this time, these two lines will be parallel, mean there is no way they will intersect either at this side or at the other side. So where our image form at, for this, our image form at infinity. It forms somewhere up here. Okay, so we say the image is virtual because it formed in front of the lens, same position with the object. Upright, form up here above principal axis, and magnified. Okay, image is bigger compared to the object. Application, eyepiece of a telescope. Okay, and last position, now it is very close to the lens where object distance less than the focal length, as you can see in this diagram. Again, you can apply rule number 1. Here, rule number 3 is not applicable because F is behind the object. So we can only apply rule number 1, the red arrow, and rule number 2, the green arrow. Okay, so they will be not intersect here because this two line will be diverged. So mean it will intersect at this side. Okay, so you continue expand this line. This will be the intersecting point. So our image is virtual. Okay, why virtual? Form at the same side as the object in front of the lens. Upright and magnified mean image is bigger compared to the object. So where to apply this position when you are using magnifying lens or magnifying glasses. Alright, so I hope you understand the 6 different position and how to draw the ray diagram to determine the position and characteristic of image for convex lens. Okay, if you are clear with this, give me number 2 in the live chat. Thank you. Okay, students, now let us continue with drawing a ray diagram for concave lens. Okay, so for concave lens, if you look or read here, image position, okay, thank you, Tol. Image position for concave lens is not depending, okay, on the position of the object in front of the concave lens. Why do I say so? Because student, for concave lens, wherever you place the object at the 6 different position as in convex lens, the characteristic of image form for concave lens will be always the same, okay, which is virtual, upright, and diminished. So that's why I say it is not depending on the, because wherever we place the object at, it will always form an image of a virtual, upright, and diminished. Okay, as you can see in this GIS, we move the object at a different position, but the image always formed here. Okay, it doesn't change. Okay, the image always form here at the position less than the focal length of the concave lens, and it is virtual. Okay, same side as the object and upright as well. Okay, you can see from this GIF to understand. Okay, so this is very easy to remember. For concave lens, it is VUD, virtual, upright, diminished. Okay, next. How to draw? We can also apply the 3 rules. So since the characteristic of this, so we take 2 example only. Okay. Now for the first example, the object is placed beyond 2F. As you can see in this diagram, the green arrow is our object. We place it beyond 2F or U greater than 2F. Okay. So we apply the first rule, rule number 1, the yellow arrow here, straight line to the optical center, undeviated, continue travel in a straight line. And we apply the second rule, straight line parallel to the principal axis, and then will be diverge. Okay, diverge from the focal point at the front. So our image form here at the intersection point between these 2 lines, it is virtual, upright, diminished. And second position, we bring it closer, U less than F. Here, our object. So we do the first rule and second rule. Again, it is virtual, upright, and diminished. Okay, so way to apply this in a lenses to correct short-sightedness in people. Okay. Okay, so that is the rules of drawing ray diagram for convex and concave lens. There are 3 rules of drawing and we have 6 different position of object. For convex lens, the characteristic is depend on these 6 different position, but for concave lens, the characteristic of image always virtual, upright, and diminished. So if you're clear with that, give me number 3 in the live chat, students. Thank you. Okay, let us move to the third activity. If you look in my screen now, this is to determine position and characteristic of image formed by convex lens and concave lens for different object distances. So this is how to determine position by doing a laboratory activities. Just now we determined the position by drawing the ray diagram. Now activity 3, to determine the distance and characteristic by doing laboratory activities. Okay, so this is apparatus and materials required. We need a convex lens, okay, with the focal length of 10 cm and also a concave lens with a focal length of negative 10 cm. And when you buy lenses in the store, there will be a description on the focal length of each. Okay, ray box with transparent paper, mark with an arrow as the object. Okay, this is our ray box. Okay, so a transparent paper is placed here, so we draw a black arrow as our object. Okay, so when we switch on the ray box, okay, so the parallel light will go through these lenses and you will see the image formed in this white screen. So we need a long ruler to measure the object distance, okay, and the image distance. All right, okay. So I guess you can read the instruction from number 1 until Number 3, we do the setup, place the convex lens at we started at the distance of 30 centimeter. Okay, mean we place the ray box, the distance between the ray box and the lens is 30 cm. Okay, and then we adjust the position of the screen until a sharp image of the black arrow form on it. Okay, so then we can observe the image form, record its characteristic. Okay, and we can print the table from the website. Actually, this one, the table you can get from your textbook. Okay, there is a QR code there. You can print the table from the website in your textbook. Okay, then we choose a suitable scale to draw the ray diagram for convex lens. Okay, then determine the position. Okay, so student, this is the, and this one for concave lens. Okay, so for this activity, this is the table of result. Okay, the table of result determined from this activity. Okay, so we have a position of object here for convex lens. This is the object distance, 30 centimeter, 20 centimeter, 15 centimeter, and 8 centimeter. And this is the position of image, 15, 20, 30, and this one, negative 40. Okay, why is negative? Later I explain to you. Okay, and this is the position of image. Okay, and the characteristic of image form. All right, so the characteristic of image form is shown here. Okay, for this one, it is real inverted. In this one, we have to look from our finding in this experiment. Okay, and students, for the first 3 position, the image is all real. Okay, all real and all inverted. Okay, this one diminish as we learned before. When the object is beyond 2F, okay, the image is diminished. And when the object is at 2F, okay, it is same size with the object. And when the object is placed between F and 2F, it is magnified. And if the object is bring very close to the object, okay, very close to the lenses, okay, here as shown now here, this one, okay. So this is how the image appear, okay, on the screen. Okay, next. So along with this GIF student, you can see the object size and the image appear on the screen. See how it changed? Okay. Yes. Okay, next. This is the result for concave lens. We place the object at 3 different positions as here. And this is how the image seen on the screen. Okay. And the image distance all negative. Negative means the image is virtual. Okay, virtual, upright, and diminished. All right. Okay, so from this third activity, this is the question that might come out. State the position of convex lens, which form real image and virtual image. So from the table I showed to you just now, for convex lens, real image are formed when the object is placed at a distance greater than the focal length. Okay, while when the image is placed at a distance smaller than the focal length, virtual image are formed. Okay, second, what are the common characteristics for real image formed by convex lens? So you can see just now from the table, all real image formed by convex lens are inverted. Okay, and what are the characteristics of image formed by concave lens? So regardless of the object distance, concave lens always form an image which has virtual, upright, and diminished. All right. Okay. So that is the third learning standard. So let us test your understanding by answering a few questions, okay, related to the third learning standard. Okay, students. Okay, can you Share your response in the live chat. Okay, for question 1, you are given 1, 2, 3, and 4. Okay, Anas draw light ray passing through lens P, lens Q, lens R, and lens S as shown in diagram before. If I magnify for you, okay, this one. Okay, this is the light ray Anas drawn for lenses P, and this is the light ray for lens Q. This is the light ray he draw for lens R, and this is the light ray he draw for lens S. All right. So the question is, which drawing shows the correct path of the light ray? Okay, which drawing shows the correct path of the light ray? So again, I magnified for you. Okay, so is this correct? Is P correct? A light ray parallel traveling at the principal axis, continue travel undeviated. So this is true, right? Okay, number 2, is this correct? We have concave lens here. Straight line parallel to the principal axis will be diverged from the focal point at the front. Okay, 1 and 2 is correct. What about number 3? Correct or not? We have a convex lens there. So a light ray parallel to the principal axis supposed to be converged at F. So here now it converged not at S. So number 3 is wrong. Okay, number 4, we have convex lens. A light passing to the optical center continue travel in a straight. So this is correct. So we have 1, 2, and 4, which is correct. So answer is C. 1, 2, and 4 only. All right. Okay, for question 2, where should an object be placed in front of a convex lens with focal length f so that it can act as a magnifying glass? Students, the keyword here is magnifying glass. Remember just now? Where we place the object when we use magnifying glass. The object is very close to the lens, right? At the position where U less than F. So clearly, yes, the answer is A. U less than F. Object distance less than the focal length. Okay, now try this. Question 3, structure question. We are given diagram 4.1, 4.2. It is a convex lens. Okay. It shows an object of two different distance in front of a convex lens. So in 4.1, we place the object beyond 2F. Okay, here U greater than 2F. Second, 4.2, the object is in between F and 2F. Okay, 2F greater than U greater than F. Okay, so the first question, state two common characteristic of the image form in 4.1 and 4.2. So this is the image form in 4.1 and this is the image form in 4.2. The one common characteristic means similar characteristic. So both image are real. Okay, both image are real and both image are inverted. Okay, that is the common characteristic, real and inverted. The size is different. This one diminished, 4.1 is diminished, and 4.2 is magnified. So two common characteristic, only real and inverted. Okay, now compare object distance between 4.1 and 4.2. The second question, okay, this is very easy. Just compare the object distance. Which one greater, which one less? So we say object distance in diagram 4.1 greater than that in 4.2 or vice versa. You can say object distance in 4.2 is less than that in 4.1. Jarak objek 4.1 lebih daripada rajah 4.2 ataupun sebaliknya. Jarak objek dalam rajah 4.2 kurang daripada rajah 4.1. Alright. Okay, compare image distance. Same. Okay, you can look image distance. This is the image distance for 4.1. This is the image distance for 4.2, which is longer. So we say image distance for 4.1 less than that in 4.2 or vice versa. Okay, image distance in 4.2 greater than that in 4.1. Okay, compare size of image. So you can compare. 4.2 has a bigger size of image, right? So we can say size of image in 4.1 less than 4.2. Okay, or vice versa. Size image in 4.2 greater than that in 4.1. Okay, now relationship. Relate. What is the relationship between object distance and image distance? So from the two diagram, you can see when the object distance increases, image distance decreases, or vice versa. You can say when the object distance decreases, image distance increases. Okay. Then second, relationship between object distance and size of image. Just refer to the diagram. This is very easy. So you can see when the object distance increases, the size of image decreases, student, or vice versa. Okay, very good. Okay, next. Okay, next question. This is application. Okay, application. Diagram 5.3 shows magnifying glass with the sunlight passing through it. So this is the light ray from the sun, okay, which is very far away. So we understand here U is at infinity. Okay, so this is the two light parallel to the entering the magnifying glass, and we place a piece of paper under this magnifying glass. Okay, so the question is where the paper should be placed to obtain the strongest heat from the sun. So where you should keep it. So you must understand, student, what happened here when a light ray traveling parallel to the principal axis, it will be converge at the focal point. Example here, if I draw, this one also will be converge at the focal point. So this is where we should place the paper at the focal point of the magnifying glass, because all the heat will be focused at that point. Okay, so answer, at the focal point of the magnifying glass. Okay, why? As I mentioned just now, all parallel light from the sun will be focused on this focal point. Okay. Semua cahaya selari daripada matahari akan ditumpukan pada titik fokus ini. Okay, so di situlah kita kena letak kertas untuk mendapatkan cahaya matahari yang paling kuat, strongest heat from the sun. Okay, it can cause the paper to be burned. Okay, alright, in further. Okay, now question 4. Okay, now you are given concave lens. We have an object here placed in between F and 2F, and it say the lens has a focal length of 2 cm. Okay, first, name the lens in this diagram, student. I mentioned it readily. The lens is thinner at the center, so we know this is concave lens, kanta cekung. Okay, now sketch the ray diagram of the object to show where the image forms. So you can apply rule number 1, rule number 2, or rule number 3. So here I apply rule number 1, a straight line to the optical center. And then rule number 2, a straight line parallel to the principal axis and will be diverged from F. So this is where our image form at. Okay, 3 marks for drawing the ray diagram. So first, this is the first mark when you draw the first ray diagram. This one first mark. This is the second mark. And the third mark is for the image. Okay, third mark is for the image. Okay. And then B2, state the characteristic of image form. So this is concave lens. So remember, it is always virtual, upright, and diminished as shown in diagram 9.3. Maya, tegak, dan dikecilkan. Okay. So let's take a short break for a while. Don't go away. We will be back after this. Okay, jangan ke mana-mana. Kita kembali lagi rehat sebentar bersama dengan iklan ini. Hello teachers and students, welcome back to our lesson. I'm Cikgu Hasnitah from SMK Bagan Jaya, Butterworth, Pulau Pinang. You are now watching an online tuition classes brought to you exclusively by Akademi Youtuber Malaysia, Kelab Guru Malaysia dan EDD Malaysia. Bermula percuma, selamanya percuma. Okay, so now let us continue with our lesson with the fourth and final learning standard. Okay, on how to explain linear magnification M, where there is a formula there where M, the magnification is equal to V divide U. V is the image distance and U is object distance. Okay, students, what is linear magnification of lens? Okay, so as you can see from our discussion earlier, when the object passes through a convex lens, some of the image will be bigger than the object and some will be smaller than the object. All right. So as the object observed through magnifying glass at a distance less than so, the image is formed is magnified. Okay, this is one example. Okay. And students, actually linear magnification is the ratio. Okay. Linear magnification is the ratio of the height of the image to the height of the object. Okay. And it is also given by the ratio of the image distance to object distance. Okay, where M equal V divide U, or M also equal to HI divide HO. So we want to know how many times the image has been magnified or how many times the image has been diminished. That is linear magnification. Okay. So this is the formula you can use. Magnification, either height of image divide height of object, or it is the ratio of the image distance to the object distance. And later when you apply this formula, when you get the value for M less than 1, let's say you get M equal to 0.85. So what happened to the image? We understand when M less than 1, the image is diminished, means smaller than the object. And if you calculated the ratio, it gives you 1. M equal to 1. What does it mean? It means that the image has the same size with the object. Okay. And if I calculated the ratio V divide U or HI divide HO, I get 2.5. So what does it mean? It means that the image is magnified, bigger than the object. So when M less than 1, we understand image is diminished. When M equal to 1, image has the same size with object. And when we have M greater than 1, we understand the image is magnified, bigger than object. All right. So this is how we understand linear magnification. Again, it is a ratio of image distance to object distance, or it is a ratio of height of image to the height of object. Later we'll see example how to find magnification using both equation. All right. Okay. Okay, let us test your understanding here. Okay, how to apply M equal V divided O, or V divided with U, or M equal to HI divide HO. Okay, we have an object with a height of 5 cm placed at a distance of 20 cm from the convex lens. Okay, a sharp image is formed on the screen 40 centimeter from the convex lens. The question is, what is the height of the image? Okay, so here in this question we have this information. We have HO, height of object 5 cm. Okay, object distance 20 cm, image distance 40 cm. So we can find HI by relating this. HI equal to HO equal HI divide HO equal to V divide U. So from here, the height of the image is 10 centimeter. Easy, right? Okay, and next question. This is the diagram, show formation of image by convex lens. This is where we place our object at. Okay, it has a height of 2 cm, okay, given in this diagram. And then the object distance is 8 centimeter in this diagram. And the distance between the object and the image is 26 cm. So the question asking for the height of image. Student, okay, so how to do this? Okay, so this is the equation we can use. Okay, height of object 2 cm. Object distance 8 centimeter. Image distance, this is V, image distance. How we get 18? 26 minus 8. So give you 18 cm. So again, we use the same formula is in question 5. So the height of image is 4.5 centimeter. Alright, okay. Answer, boy, 4.5 centimeter. Okay, this is an additional notes. It is not in your textbook. What is power of a lens? Okay, students, power of a lens refer as the ability of the lens to bend or to refract light ray which pass through it. And power is measured in a unit of diopter. Okay, so thicker, the center for a convex lens. Okay, a thicker convex lens has a higher power. Okay, thicker convex lens has a higher power. Okay, and mentioned here. Okay, the thicker the center of convex lens, the shorter its focal length, which means the higher the power. And power and focal length is related to this equation. Power equal to reciprocal of focal length. So you can see for convex lens, when the lens are thicker, the focal length will be shorter, which means the power will be greater. Okay. Okay, then what about a concave lens, student? For concave lens, okay, the thinner the center of the concave lens, the shorter its focal length and the higher power the lens have. Okay, for concave lens, thinner concave lens has a higher power. Okay. Okay, now let us take a look at the next question. Regarding the power and focal length of a lenses. Okay, they give us this situation in question 7. Focal length of a convex lens is 20 cm. So what is the power of this lens? So how to find power? This is the equation. P power equal to reciprocal of focal length. Reciprocal mean 1 over F. And F must be in meter. Okay, in meter. So 20 centimeter is 0.2 meters, so 5 diopter. Okay, and for question 8, we have a concave lens with a focal length of 10 cm. So what is the power of the lens? Okay, power of the lens, negative here. Why I put negative here, student? Because for concave lens, it has a negative focal length, virtual focal length. So it is negative. While for convex lens, the focal length is positive. Okay, real focal length. Okay, next. Okay, let us try this question. Question 9 and 10. All right. So in question 9, diagram 5.1, okay, we have a ray diagram of the convex lens with a focal length of 35 millimeter in a camera. Produce image of with a height of H1. Okay, this is the image formed in 5.1. While in 5.2, we have a diagram of a convex lens with a focal length of 50 millimeter. Okay, so the difference in 5.1 and 5.2 is the focal length of the lens. Here is 35 millimeter. This one 50 millimeter. And this is the height of the image produced, H2. All right. Okay, first question. State the light phenomenon involved to produce image by convex lens. Okay, what is the light phenomenon involving lenses, students? Yes, very good. The light phenomenon is refraction. Okay, refraction. And now observe both diagram. Compare the thickness of the lens. Can you observe and differentiate the thickness of the lens? Obviously, the lens in 5.1 is thicker, okay, or it has greater thickness compared to that in 5.2. Okay, compare the focal length of the lens. This one 35 mm, 5.1. 5.2 is 50 mm. So we can say 5.1 less than 5.2 or vice versa. 5.2 greater than 5.1. Compare the height of the image. compare. So obviously H2 is higher, okay, compared to H1. So you can say 5.1 less than 5.2 or 5.2 greater than that in 5.1. Or you can also write H1 less than H2, H2 greater than H1. Okay, no problem. Okay, next. Okay, next question. Based on your answer in B, okay, now we do the relationship. Thickness and focal length. So it is inversely proportional. Okay, for this one, you can write when the thickness increases, the focal length decreases. I prefer that answer. Okay, when the thickness increases, the focal length decreases. Okay, then relate the focal length with the height of image. Same also, you can write when the focal length increases, the height of image increases. We can use inversely proportional, directly proportional only if we have formula relating them. Okay, so here the recommended answer is thickness of the lens increases, focal length decreases. And this one, focal length increases, height of image increases. Okay, okay, next question, Kibat. Okay, D. A leaf blown by a strong wind cover the upper portion of the convex lens in 5.1. The question is, what will happen to the size and brightness of the image? A leaf blown by and cover half of the portion of the convex lens. Any changes on the size or any changes on the brightness? So student, nothing happened to the size, but the brightness will be decreases. Okay, because when the leaf cover mean less light will be entering the lenses. So the size unchanged, but the brightness decreases. Wrong spelling there for brightness. Brightness decreases. Okay. Okay, question 10. We have this diagram. It is an image seen through a lens. Okay, this is the lens. We have a circular lens there. This is the image seen through the lens. Okay, first, again, name light phenomenon involved. So what is the light phenomenon involved here? Refraction of light. Draw a ray diagram to show how the image forms. Okay, first you must understand what apparatus we use here to see this image. So you can see the image is bigger. It is actually a magnifying glass where the object is less than f. Okay, so we draw the first rule and the second rule. So this is the intersecting point where our image form at. Okay, so next question, the focal length of the lens in diagram for 8.2 is f. Okay, this is the next question referring to f. Suggest a suitable position to place the object to produce an inverted image. Okay, so to produce an inverted image, okay, we should place the object at the position greater than f. Okay, I think this one should be 8.1. Okay, focal length in diagram is f. So the question asks you where we should place the object now to produce inverted image. Okay, so according to the table just now in 6.3, to produce inverted image for convex lens, the object must be placed at the position greater than the focal length. All right, okay. Okay, I think this is our last question for this evening, an essay question of 10 marks on modification. Modification mean in section C, okay, a compulsory question 11. Okay, diagram 11.4 shows the basic structure of a smartphone camera. This is the smartphone camera. This is the structure inside, okay, the sensor, the lens, and the camera aperture. All right. The problem with this camera, student, it is found that the image produced is blurry. So it forms a blur image. Okay. So what you must do, you are required to modify the smartphone camera so that the camera lens is durable, number one. Number 2, not easily damaged. And number 3, can produce a clearer image. Okay, so describe and explain the modification you will make to the lens characteristic, including the focal length, the optical density of the lens, the aperture size, and any supplementary tools or features you will add to the lens of the camera aperture. So it is quite challenging. You should do modification to get camera lenses which is more durable, not easily damaged, and produce clearer image. So how we respond to this question, as usual, you are very recommended to put your answer in table, modification, and reason. For this question 11 student, you can give more than 5 suggestions and more than 5 reasons. Okay. So first, we focus on the focal length. Okay, so the focal length should be longer. The lens should have longer focal length. Why? So that it will produce bigger magnification or will produce bigger image. Okay. Second, the lens must have high optical density. We use a high optical density lens. For what reason? So the smartphone will be thinner, okay, or it will has a longer focal length. Okay. Second or third, big size of camera aperture so that more light will enter the camera. By this, it will produce a brighter image. Okay. But you cannot write brighter image here because it is stated in the question. So we say more light enter or more light will be refracted. Okay. And then this is the additional tools we can add. Add transparent lens cover. Okay. Or screen cover. Add transparent lens cover for what? To prevent dust or to prevent scratches on the lens surface. And last but not least, you can use a lens which has low rate of oxidation. Okay, why? For what reason? To prevent blur lens. So it won't oxidize easily. It won't or prevent the lens from oxidize. Okay, or prevent blur lens. Okay, so that is the suggestion and modification reason we did for this question. Okay, so I guess that's all for tonight. I have discussed with you 6.3 image formation by lenses. Okay, so we have studied what is convex and concave lens, how to draw the ray diagram to determine the characteristic and position of image form. And we also learn how to determine the magnification, linear magnification, by applying the formula of HI divide HO or V divide U. And last but not least, we have responded to a few example of question exercises on lenses. So I hope this lesson will give you a better understanding in this chapter. And don't forget to fill up this e-certificate link. Just fill up with your name and IC number, and the cert will be generated to your email. You can use any types of email as well. So I guess that's all the time we have for today. Thank you very much again for your time, and thank you very much for your effort. Don't forget to be with us again same time next week. I will continue with 6.4. It is thin lens formula. Same time on Sunday 8 past 15 PM. Okay, so thank you very much. Terima kasih. Alhamdulillah. Itu saja masa yang kita ada buat hari ini. Terima kasih kepada semua yang bersama-sama dengan cikgu daripada mula sampailah akhir. Cikgu doakan anda berjaya dalam peperiksaan akhir tahun untuk murid tingkatan 4 dan tingkatan 5. Teruskan mengulang kaji and prepare your best for your incoming SPM. Jadi, sekian saja pada cikgu. Yang baik itu daripada Allah, yang kurang itu daripada kelemahan dan kedangkalan ilmu saya. Semoga sesi ini mendapat berkat daripada Allah SWT dan kita jumpa lagi dalam masa yang akan datang. Terima kasih. Assalamualaikum dan selamat malam semua.
Marah semua para ilmuwan, semai ilmu kepada anak wawasan, tak kira di utara selatan, sampaikan ilmu penuh kesungguhan. Akademi Youtuber Malaysia, rangka laksana dengan jitu, penuh bermisi guru AYU, mencapai misi yang satu. Permisi kita, bantu kita, bermoto sendiri yang kita biasa, bersama kita luar biasa, berjasa demi nusa bangsa.
Akademi Youtuber Malaysia, berpadu bersatu keluarga AYU, memberi ilmu tanpa jamu, siap sedia menyumbang ilmu.
Ilmu diberi juga dikongsi pada semua generasi yang terkini, lahir generasi yang berkualiti, sedia berkhidmat pada pertiwi. Akademi Youtuber Malaysia, rangka laksana dengan jitu, penuh bermisi guru AYU, mencapai misi yang satu. Permisi kita, bantu kita, bermoto sendiri yang kita biasa, bersama kita luar biasa, berjasa demi nusa bangsa. www.academyyoutuber.com. Berusaha AYU capai kecemerlangan, berpadu AYU cipta kegemilangan, bersatu AYU bina wadah terbilang, terus berjaya bersama AYU.
Berusaha AYU capai kecemerlangan, berpadu AYU cipta kegemilangan, bersatu AYU bina wadah terbilang, terus berjaya bersama AYU.
Marah semua para ilmuwan, semai ilmu kepada anak wawasan, tak kira di utara selatan, sampaikan ilmu penuh kesungguhan. Akademi Youtuber Malaysia, rangka laksana dengan jitu, penuh bermisi guru AYU, mencapai misi yang satu. Permisi kita, bantu kita, bermoto sendiri yang kita biasa, bersama kita luar biasa, berjasa demi nusa